All right, what we're going to do today is we're going to get this robot running. I want to be able to control it just remotely from a remote control transmitter, and that's the first stage before we start adding some extra brains to it. So the first thing we need to do is I've got the cabling hooked up such that this Flipsky Dual FSESC can drive the two main wheels, and we are going to give it a quick program here with the VESC Tool. And to do that, I'm going to start with the left VESC here. Got that right? There we go. I'm going to turn him on. And you see the two green lights. We should be in good shape to start programming. Keep the cable out of the way. All right, we've got this one hooked up there. First thing we're going to do is come over here and auto connect. All right, so this is going to show our CAN devices over here. There's a motor called ID number 60, local. Let's set up the motor. This always freaks me out. We're going to do a medium outrunner next. Yes, I know it's going to explode. 3, delete 10. I've got a 10 series battery, and that's P3, so it's 12 amps. Next, it's direct drive. There's no ratioing, and the diameter on the wheel is 25 centimeters. So we can run the detection no cam. Warning, it's going to make the wheels run. It's always freaky. It's going to make this wheel here jump around, and let's see how that works. So it's doing its testing now, trying to identify how the Hall effect sensors are situated and lined up. And it's doing that back and forward, and should finish pretty soon. Come back over here. We see that it is made some determination about the motor and so forth. Now it's going to give us an opportunity to say whether it's going forward or reverse correctly. We'll say drive it forward, and it's driving it in that direction, which from my perspective is forward, so we're good to go. And we'll leave this checkbox inverted. Okay, finish. I always follow that with a right for the motor, a right to the hardware. I think it probably does that anyway, but now it's there. And then we're going to set up input. This is where we're going to use, before I proceed on that actually, just going to power it down. And I'm going to connect a receiver. This is a Flipsky receiver, and I'm just going to, on this one, I'm going to connect it into AUX1. AUX1 is going to be this guy here. AUX1 set up there, and I've got this little breakout thing here, and it's going to connect this into the right pins for my particular situation. I'm going to run it on the pulse position modulation, the PPM. So we've got PPM, 5 volts, and earth as the first 3 pins on both of these. So I'm going to run that in there, and that's what's going to be sent out of here. So AUX1 on this side, and we'll do that. Now I got this thing here, when I turn it back on, is going to get power, and that's already bound to my transmitter. You can see because the light's on and all, so we should be in good shape. Otherwise there's a binding step that would need to happen as well. So let's go ahead and set up that driver. Okay, now that we have this wizard set up here, I'm actually going to have to go and reorder connect because we rebooted it. And motor local, don't need to set up the motor there. I will grab it from the machine, so I'm grabbing it, and then we're going to do set up the inputs next. Sometimes this confuses itself. Like this, it says that you need to update the firmware on the VESC tool. That's not true. You just cancel and try again. And then we can come in here, select that we want a pulse position modulation controller from an RC receiver. Next. And then we grab the transmitter, and what's doing it here is we're setting the ranges that we're going to use. So I've got the transmitter here, and first thing I'm going to do is tell it that I want duty cycle. So the first thing we need to do is we need to set up a mix on here to route the elevator, which is what I want to use for forward and back, to auxiliary 1. The way we do that is we're going to drop in here into mixing, and we're going to pick the first one, go in here, select mix 1, leave the name, normal curve, leave the name, it takes too long to set up, and then you've got inhibit, we're going to change that to elevators. And then we've got, we want to route that out to aux1, because that's what we plugged into our robot over there. The rate, I want to set it to 75%, and the reason I don't want to give it a whole 100% in each direction is that I want to save some overhead for, some headroom for turns. So here, because I've got to do tank turns, I'll show you that in a minute. So the rate is going to be 75%. That means when I go forward, you'll see aux1 down here, aux1 going up. When I go up 100% on the elevator, it's going to go to 74, 75 on that. And then this is saying what happens when you go backwards. Same thing, I don't want to change the direction. I just want it to go the same direction as the elevator. So when I push down, it's going to take aux1 down with the elevator. So you can see that happening. And in fact, if you look on the screen behind, you can now see that when I move the elevator forward and back, we got that going on. This is fine for testing. We're going to have to redo it in a minute because of we're going to change the way that works in here. In fact, the maximum will be different in a minute, but we can test like this. So duty cycle, we've done our back and forth. We're going to do our apply. Next, change this back to duty cycle. I don't know why it does that. General. Down there, traction control, false, whatever. Right to VSC. Next, we should be good to test it. Let's see if that is actually true. I can now go, when I press the elevator forward, we've got this wheel moving forward and this wheel moving back. Okay, so that's not the end of the story though, because we need to be able to turn as well. So we can do the same thing on this one, and that would set that one up in the same way. But and I'll do that now for the mixing. So what we're going to do is we're going to come back out of here. That's fine. We're going to drop into mix number 2, and we'll do the left. We're going to do that on aux2. So we're going to come in here and say normal, skip the naming, also set the elevators to drive aux2. So that means that when I push the elevator forward, it turns both wheels on. I'm going to set that to 75% as well. Next one, 75%. Okay, so that should now get us, when I connect this other one, which I haven't done yet, but when I connect this one, you'll see on the screen here that when I move the elevator forward, both AUX 1 and AUX 2 are now going up. And when I push them back, they're going down. So we have now connected the elevator to AUX 1 and AUX 2. What I want to do, though, is take this turning, the ailerons, into account to drive my turns. So I'm going to do that by going back into a mix, adding a couple of other mixes that say, add a mix here. Normal. And we're going to go into and say that my ailerons are going to drive AUX 1 as well, but only at a rate of 25%. And let's see if we got that right in a sec. 25%. That's going to fill up that 70. We did the other one at 75%, so we've got some headroom. So we're going to add 25% of the aileron into the AUX 1. So now when I push up AUX 1, I can take it even further by bringing across the elevator there. So it should be able to drive it just by using the aileron. So I bring the aileron in, I'm driving AUX 1. And I can do that by having a little bit forward, but then this way. And so, in fact, what I'm noticing is that this is increasing the speed of this, which means that it would, in a tank turn, this is the left wheel, you want the tank turn to turn right. You want this one to go forward when you're turning right. But at the moment, I've got it going backwards, and this one, I want to turn left. I want this wheel to go backwards, not forwards. So I need to go back into my mix and change this from 25 to -25. That means that when I'm turning left, the left wheel will go backwards, and when I'm turning right, the left wheel will go forwards. So now when I turn left, I want the left wheel going backwards. I don't know if you can see that there. And when I turn right, I want the left wheel going forward. Okay, so what I just did then was change the maximum amount that that AUX 1 can go to. So what I'm going to have to do is go back out of here. Now that I've set the mixing up, I'll do that while I'm here. I'll set the mix up for the other wheel as well, AUX 2. Normal curve, come in here. We want the aileron to go out to AUX 2. And in this case, I do want it to be positive. Okay. And so now this is configured, but it is a bit different from how we just set it up. So we're going to reset it because it did measure how much it could, what the max and mins were on the RC inputs. So we need to go reset them. Once again, I have to tell it to ignore that nonsense. Come back, try again. Sometimes you have to try several times to get it to go through, but this time we'll see. There we go. We got a receiver. That's cool. Come in next. And change this to duty cycle. And now I want to be the maximum. I think it's turned this off now, yeah. So the maximum that AUX1 is going to go to, I want to see it on here. So AUX1 is going to get maximum when I take it both forward, full elevators and ailerons to the right. And it's going to be minimum when I take it the opposite corner. So this is now giving me the full range of what the RC is going to deliver to the ESC. And then I'm going to come down here and I have to change this back to duty cycle. Come down here, write the configuration to the VSC, and then we are done. And then we can see this again working, going forward. If I want to turn left, it's not working. It's not making it out of the dead zone is what's going on there. So with the let me try that again. So there's too big a dead zone. We need to make the dead zone smaller. Set up input. Duty cycle. So the dead band in here, I'm going to drop that down to 10%. Okay, apply that. Come up here, duty cycle. Right to VSC. Next, see how that goes. Okay, so that's perfect. Slow turns on the spot. Okay, and now it's just a matter of doing the other one. So I am going to power down and do the whole thing again. Transfer this cable across to the other one. Connect these wires to AUX2. AUX2 is adjacent to AUX1. Should be fine. Powered back up. Make sure that's free. Okay, got the goods over there. We'll do the same thing we did last time. Come here, auto connect. Set up the motor. Medium outrunner. Next. Yes, I can blow it up. Battery cells. 10, 12 milliamps, 12 amp hours. Next. Direct drive and the same diameter. Run detect. See what my motor is doing over there. Freaks me out every time it does that. Looks like it's going backwards first. And it's going to slowly go forwards to try to detect the Hall effect sensors. And then it's going to finish up. And we get to see whether it's oriented correctly, forward versus back. Try going forward. And that's backwards for me, so I'm going to invert this. Try again, going forward. That's forward for me. Okay. Finish. Write the motor configuration. Go into the application setup. Next. Does that again. We just lost our lights. PPM inputs. There we go. Next. Change this to duty cycle. Change this to a 10% dead band. Get our receiver. And so that's the full range. Apply. Okay, that should be good. Next, change this again to duty cycle. Come down here, write it to the VSC. Finish. And now we should have both wheels running. There's forward, there's back, here's turning to the left, turning to the right. And then we can go forward and back. And we should have a functioning robot. I'll reset it and we'll take it for a spin. Okay, here we go. Can drive forward. Oh, we've got to turn it on. It's bound. I think we should be good to go. Drive forward, drive back, turn on the spot, turn the other way. Oh, let's go back a bit. And we are good to go. There is our tank drive robot configured from scratch using the Flipsky Dual FSESC controllers and the NX10 radio control and receivers from Spektrum. There you go.